Ready.
Okay, there she is, right there.
Hi,
So-
Casey, thank you.
I want to introduce all of you guys to this brilliant young woman. Casey is, among other things, my daughter. She's also a third-year biomedical science student at University of Ottawa. And she's a member of the Algoma Vaccination Support Committee. Just created the Science Communication Subcommittee today to do presentations like this. So we're sort of her guinea pig. I had heard some people saying they were a little bit worried about the vaccines. And I mentioned it to Casey and she said, well, would you like me to do a presentation for you guys? And I thought, well, sure, the price is right. Definitely we'll have a presentation. I'm really excited that so many people have showed up here. And I'll just hand it over to Casey to tell us about the COVID vaccine and virus. And if you guys have any questions, she's ready to answer any questions that you've got. And if she doesn't know the answer, she'll find it for you. So feel free to ask anything because I don't want people to be concerned or afraid of this. So over to you, Casey.
Yeah, well, thank you for the introduction. I'm excited to be here today. I'm pretty passionate about getting people vaccinated because I want to go outside. And I'm sure a lot of other people here do too. So just to start, I have this little box here that's not showing up. 1 minute. This little box here to kind of just let everybody know that I don't have the appropriate credentials to give you medical advice right now. This is more just for your own information. And here's my outline of what I'm going to talk about. I want my laser pointer. So first I want to start with like the structure of the virus so we can talk about how it is that we're targeting it and how we can stop it with a vaccine. Because the vaccines that are in the SU right now are the mRNA vaccines, I'd like to talk about what mRNA actually is. I will talk about types of vaccines. There's 3 different types going out right now about the COVID vaccines. And I'm going to go into more depth on the mRNA, the Pfizer and the Moderna vaccines. I'd like to talk about what they actually are doing to your body. And I'd like to compare it to what COVID is doing to your body. And then we'll do a little bit of myth busting. And then I've got some extra resources if you have questions. So to start here, I've got the structure of COVID. This is what COVID looks like right now. It's called a coronavirus because the spike proteins make it look like a crown. That's how it gets its name. And what I need you to get from this slide is that the genome is non-segmented, which means it looks like this instead of looking like this, which is what the flu vaccine, or not the flu vaccine, the flu virus looks like. And whoops. Outside, there are these spike proteins that I talked about earlier. And these spike proteins are what bind to receptors on our cells and let it get taken up by our cells to cause all the problems it causes. So we target these spike cells in vaccines because we don't see them in our bodies, and they're what's letting the virus get into our cells. So here we go with the what is mRNA. There's mRNA in your body right now, I can tell you that much. mRNA stands for messenger RNA, and messenger RNA's job is to take information from DNA, which is in this part of your cell called the nucleus. And DNA is in this part of the cell to keep it safe. So it doesn't ever leave here. And the entry of substances into here is very, very controlled. So mRNA allows us to take the information from in here out into this part of the cell where stuff actually happens without damaging the DNA. So we go from DNA to this mRNA here, and this mRNA can be made into proteins, and proteins do all the functions in your cells. And a lot of people, when they talk about the vaccine, they talk about how they don't want mRNA in their body. So I've got this point here to say that the half-life of mRNA is from 2 minutes to 10 hours, and that's really short. So that means if I was to put 8 molecules of mRNA in your body, within 2 minutes, half of them would be gone. So it's not there for very long. And to kind of elaborate on that, if it's dangerous, short answer, no, it's not. And in the vaccine, mRNA can only enter cells if it's covered in this lipid nanoparticle thing here. So basically you just need to put like a little cover on it to let it into your cells. So this is how we don't just randomly pick up mRNA from stuff. This is what it looks like normally, and then we put it in here. And what the cell does is this is the cell, like here, this is the cell, this is your cells. It'll kind of create a blanket and it'll cover this lipid nanoparticle here. You can see it here. So it'll actually pinch off part of your own membrane like this, and the mRNA will be in here. So this way it can get into your cells, and it can only do stuff once it's in your cells. And an important point is that mRNA does not enter the nucleus, so it will never come into contact with your DNA. It's difficult enough to get mRNA out of your nucleus when it's produced by your own DNA, so it's almost impossible to get it back in there. And another thing is mRNA cannot become DNA without a special enzyme that we don't really have in our body, so there's no way for it to become the DNA to mess with your DNA. And you also need a second protein called integrase to let it integrate into your genome. So you need both of those proteins present for mRNA to have any damaging effects, and we don't have them. So I thought I'd go over, these are the 3 types of vaccines that are in development. The first one is protein-based, where we take a spike protein, we purify it, and then we put it into your body to create a response. The second one is viral vector. This one's cool. You take the gene for the spike protein, you put it in a harmless virus, and the harmless virus in your body makes the spike protein, and then that gets the response. And then the third one, this is the new one, this is the mRNA. So we take the mRNA, we put that into your body with the lipid nanoparticles that I was talking about before. Your body produces a spike protein, and then we get a response. I'll go into these in a little bit more depth. I've got like a step-by-step mechanism here. So we have to make the spike proteins first. So we add the gene for the spike proteins into insect cells in the lab. This is done with recombinant nanoparticle technology. So we grow the proteins in these insect cells, and then we purify them. So we get rid of all the insect cell parts. It's just the spike proteins from COVID. We add them onto like a carrier molecule. So hold on, I can draw that. So we've got our little carrier molecule here, and we'll stick a whole bunch of spike proteins onto it like this. Probably. And then so we add the protein carrier here that's in the way now with an adjuvant, and then we inject that into the patient. The spike proteins are recognized as foreign by the immune system, so they start targeting and destroying them. And once they've recognized it and they know that you could come into contact with it again, they keep a memory of it, so they're prepared basically to fight it again. So upon another infection, immune cells will recognize and attack the proteins. And an example of a protein-based vaccine is the Novavax vaccine here. And one advantage of this type of vaccine is it's a single dose, but it's not here in the SU yet, so I don't have that much information on it. I'd like to spend my time talking to you about the vaccines that you might be encountering. So the second one is the viral vector. I have adenoviral here because you use a harmless virus called adenovirus. So we add the mRNA for the spike protein into this virus. We put the virus into the patient, and then the virus will actually inject the spike protein mRNA into cells. And then the same way that the mRNA vaccine is going to work, the body produces the spike proteins, we recognize the spike proteins, we target, we destroy them, we get a memory, and then we can prevent further infection. And then we've got the mRNA. Oh wait, I forgot the examples. So the examples are AstraZeneca and the Johnson & Johnson one. And I'm going to come back and talk about AstraZeneca some more because I know that people are having second thoughts about getting it. So the mRNA vaccine mechanism is very similar to the viral vector one, except we make the mRNA, we freeze it, and we purify it. Because of how short the mRNA half-life is, we need to freeze it so it doesn't immediately just degrade before it can do anything. We add it to the lipid nanoparticles that I was talking about earlier. We might add some other ingredients to make it a liquid to keep it stable. I'll talk about that. We put it into the patient. We read the mRNA, we make it into the spike proteins. We recognize the spike proteins as foreign. We destroy them. We get a memory, and then we can prevent further infection. And the 2 examples of this that are big is Pfizer and Moderna. And I'm going to go into a lot more detail on Pfizer and Moderna because those are the ones that are readily available in the SU right now. So I'll start with Pfizer. And this is the list of all of the ingredients in the Pfizer vaccine. This is all of them. There's 7. We talked about mRNA. Lipids are fats. These make up the lipid nanoparticles to go around the mRNA that I was talking about. And then they have some additional ingredients here to keep it stable and keep it liquid and keep it safe to put in our body. So potassium chloride, if it sounds scary, that's a salt replacement for people who are have too much sodium in their body. We have monobasic potassium phosphate here. That's a mineral supplement, not scary. We have sodium chloride. This is your regular table salt. We have diabasic sodium phosphate dihydrate. And what that does is it helps stabilize the mRNA, and it helps make sure that, or it's an emulsifier, and an emulsifier will keep your liquid, because the mRNA is coated in fat, it doesn't mix with water. If you've ever put oil and water together, you know that. An emulsifier makes it so that you can put oil and water together a little bit better. This keeps the vaccine in the vial. There's the same amount of mRNA throughout, and that's important. And then we've got some sucrose, which is just sugar. And I'd like to compare the 7 ingredients in the Pfizer vaccine to the 72 ingredients in a Big Mac. And these are just 3 of the components. We've got the cheese, we've got the bun, and we've got the sauce. I don't even have the pickles or the lettuce or the other sauces or the burger, because I couldn't fit it all in one slide. There were so many. So if you're worried about the amount of ingredients, don't be. So a lot of people are afraid of the vaccine and they want to know when it's unsafe. And the only time the Pfizer vaccine is unsafe for you is when you are allergic to it. This is taken right off of the Pfizer website. This is the only people who should absolutely not get the Pfizer vaccine. If you've had a severe allergic reaction to a previous dose or any ingredient, so if you are allergic to table salt somehow, talk to your doctor. And you should also talk to your doctor if you have other allergies that you're concerned about. If you have a bleeding disorder or on blood thinner, that's for the needle. If you are immunocompromised or pregnant or plan to become pregnant, talk to your healthcare provider and see what they think about it. I have side effects. This is side effects for all of the vaccines, not just the Pfizer. But you'll see injection site pain, tiredness, muscle aches, chills, fever, some swelling, and maybe some swelling in your lymph nodes. And this is good. This is your immune system working. This means that your body has found the spike proteins and it's doing what it's supposed to be doing. So injection site pain is because you got a needle. You're tired because your body's trying to conserve energy to fight the virus. You'll get some aches and chills that come with a fever. And the point of a fever is to try and get your body hot enough to slow down the process of replication. So the virus uses proteins to replicate, and proteins, when they get too hot, they fall apart. So that's the point of the fever, is to get these proteins that are replicating the virus to fall apart so they stop. You'll see some injection site swelling. And swelling is a really good sign because it means your body knows that there's something wrong, and it's swelling to try and convince your immune cells to go there. And if you see that, you might see some swelling in your lymph nodes because some of your immune cells will bring the virus to your lymph nodes to fight it better. So that's all I've got for Pfizer, and here's Moderna. And this is going to be very similar because they're very similar vaccines. So again, we've got mRNA and lipids, which we covered. We've got tromethamine, that's a buffer. And a buffer is something that keeps the vaccine's pH, which is the acidity level, the same as your body. So it's safe to put into your body. And we have lots of buffers in here to keep it nice and safe. Buffer, vinegar, buffer, because it's acidic. So we've got acids and bases, which counteract acids in there. Buffer, sugar. So we've got 7 more ingredients, and we can compare that again to the 72 ingredients in a Big Mac. And again, the Moderna vaccine is unsafe at the same times as the Pfizer vaccine. I took this right off of the Moderna site, same thing. So again, talk to your doctor. If you are concerned, talk to your doctor. And now, it's important to know what the vaccine is actually doing to you. And I'd like to start that with talking about what COVID does to you. So we have natural immunity, which is actually getting COVID-19, and your body will try and fight it by killing all the cells that have COVID in them. So we'll put some COVID in this cell here, and then we wait a minute. So the virus has time to replicate, and it has time to get ready to go to other cells. And then we'll have a immune cell come, and it'll recognize that there's something wrong, and it'll cause your cells to explode. And this is bad because we have all of our cells in our body for a reason. And if we keep causing them to explode, we don't have enough, and this can cause damage. So it can cause scarring. And COVID attacks your lungs primarily. So that will result in lung scarring. That's what happens when you actually get like the coronavirus. And I just wanted to talk about the consequences of COVID, actually getting it. It's a respiratory illness, like I said. So it affects your lungs. And if you are dying from COVID, it's pretty gruesome. I have some pictures here. This is what your lungs look like normally. They're nice and clear. You can see your heart here. This is your diaphragm. This is the muscle that lets you breathe. It's nice and flat. I have bacterial pneumonia here. I've had bacterial pneumonia so many times, and I know it's super painful and awful, and it feels like you're suffocating. And if you compare this image and how clear it is to this image with COVID, you can see how much worse it is here. Your diaphragm is all the way up here because it's working so hard. You can see stuff in all of these little vessels here. It just looks awful. So it feels like you're drowning or suffocating because there's fluid in your lungs, there's viruses in your lungs. And one thing to consider is a lot of people who die from COVID die alone, right? Because you are isolating. So to me, that just sounds like a really awful way to go. So to prevent that, we have vaccines. And the goal of vaccines is to prevent the spread. That's our main goal. That's what we really want to do. But, that's kind of difficult. So we want to get a vaccination rate to achieve herd immunity. So I talk about this. This is called R0, and I don't know if you've heard about it in the news now, but R0 is how many people one infected person infects. So here I've got R0 is 0, so one infected person doesn't infect anybody. R1, one infected person infects one more person, and this will just keep going. This is linear. You'll get 1, 1, 1. But the issue comes when R0 is more. So one infected person can infect two infected people, infect two more people. And each of these people can go on and infect two more people, and we get a lot of spread. So in order to try and get R0 below 1, so one infected person infects one or fewer people, we need a 53% vaccination rate. And take this number with a grain of salt because we have the variants coming around now, and people could get really irresponsible and this number could become a lot higher. So a good way of making sure that we achieve herd immunity is getting as many people vaccinated as possible. So we usually aim for 90 to 95%. And getting the vaccination, you're trying to prevent the spread of COVID. So we're still doing research on whether you can spread COVID after you've been vaccinated. Early studies show you're not a carrier, and I have this diagram here to explain why. So here's the virus before it goes into your cells. The spike protein interacts with the receptor, and then it goes in, and inside the cell is where it replicates. And this is where we make all of the different viral particles that go back out. So if we prevent the cell or the virus from getting in, it can't make more viruses. So you can't really spread it all that well. And that's my logic behind it. But, still be safe, obviously. Don't not wear a mask because we don't know yet. We're still doing the research. And this is a speculation slide from me. This is the future frequency of vaccination. So I wanted to compare it to influenza. And like I said earlier, influenza has that segmented genome I was talking about. So it looks a little bit like this, whereas COVID looks like this. And I've kind of put those here. So I've compared influenza to puzzle pieces, COVID to a stick. So Influenza mutates really quickly. It doesn't have any proofreading ability. And also, if you get infected with two different strains of influenza, if you get infected with one green and one blue, they can recombine in your cells and you can get this hybrid. And we don't have that much immunity for this hybrid here. So that's a good representation of why we have to get vaccinated every single year for this. And so COVID doesn't have that. Even if you get infected with two different strains, they can't recombine the same way that influenza can. And COVID also has a little bit of proofreading ability. So if it makes an error and it mutates, it can change that back because COVID is a really big molecule. And in big molecules, it's a lot easier for a mutation to cause something to go wrong. So I just want to bring you through a few facts that people are spreading. This one's been around forever. Vaccines cause autism. They do not. One study has ever showed this, and they used a small sample size. They tested this on 12 people, and in comparison, the last phase of clinical trials for the Pfizer vaccine used 43,000 people. So this is not enough people to show an accurate representation, and researchers were paid to target this outcome. So 13 people worked on this paper, and 10 of these people have since renounced it. They've said, no, this is not true. They were accused of fraud, and the person who ran the study, Wakefield, he lost his license to practice medicine altogether. That's how bad the study was. So this is not true. Another one I've heard is that there are microchips in vaccines. COVID was invented to microchip us so they know where we are or whatever. So I just wanted to show you what a microchip needle looks like. This is big, and this is not. So we don't have the technology to make a microchip that would fit in this needle yet. And if we did, you'd see it in here. It would probably clog up this. It just doesn't make sense. It's not possible. And sadly enough, 28% of Americans believe this. So I have to put this here that the virus was not invented to inject people with microchips. It's invented to make sure that you don't get COVID. So false. So here I'm coming back to AstraZeneca. I know there's been a lot of issues with it lately where people think that it is dangerous. And I just have a few stats here. So when we're working on vaccines, we have to compare the benefits and the risks. So the benefit is you do not get coronavirus, and the risk is you could potentially develop a blood clot. But the rate of developing blood clots right now is 1 in 100,000 or less. I've seen 1 in 200,000, I've seen 1 in a million, so I used the biggest number I could find, which is 0.00001%. That's pretty small. And that's the rate of getting blood clots. So 30 people have gotten the blood clots and 7 have died. That's a rate of 23%. So we're going to say you have a 0.00002% chance of dying from a blood clot from this vaccine. We can compare this to the death rate of the coronavirus. Worldwide, that's 3.4%. So worldwide, if you were to get the AstraZeneca vaccine or get COVID, you are 17,000 times more likely to die of COVID. And I even compared it to the Algoma COVID death rate here. It's lower, it's 1.7, but you are still 8,500 times more likely to die of COVID in Algoma than from the blood clots from the vaccine. And this is not new. This is not the first time a drug has caused blood clotting. We live with this almost every day. So I'd like to compare the risk of blood clots from the vaccine and birth control pills. And I would like to acknowledge how common birth control pill use is in our society. So the benefits of birth control still outweigh the risks, so we use it. But the rate of getting blood clots from the vaccine is this 0.00001. But the rate of getting a blood clot from birth control is much higher. It's 0.3 to 1%. So this is a 300 to 1,000 times increase, but we still use birth control every day. And another thing to consider in the comparison is people take birth control daily for an extended period of time. And you get the AstraZeneca vaccine twice, and then you are finished. So it's not unsafe. False. This one I hear a lot too. The COVID vaccine development was rushed. And I have to write papers on this all the time now, which is great. And I can tell you that the COVID vaccine has undergone the same testing standards that other drugs use. So I've got the stages of trials here, and these are the overlapping trials that they use in COVID. So we start with research. This says skip research. I hate that. We use research from previous processes. We do our preclinical. And in here, before we even get the vaccine in people, we know approximately what dose to use. We know how toxic it is. We know what it's going to do. So we know all of that. And then we get into people. And there are 3 phases here. Phase 1, we try and find the safe dose range. So we find the minimum dose that's safe and the maximum dose that's safe. We start to look for side effects. And this uses a very small amount of people just to make sure that we're completely sure that it's safe. And then we do phase 2 here. We make sure that it works. We find the dose that we want. And we continue to look for side effects. We're looking for side effects the whole time. Phase 3, we compare it to another standard. So for the COVID vaccines, we didn't really have another standard, so we had to compare it to not getting vaccinated. And you might notice that these clinical trials can overlap. That's special to COVID. Usually you have to do all of phase 1 and then all of phase 2 and then all of phase 3. But we've overlapped them. So as soon as you have the safe amount of information, you can move on. But you continue with that phase 1 until you are 100% certain. So we're not missing any parts of clinical trials. We're just doing them we're doing them in an overlapping period. So another thing is in research, a lot of your timing is based on funding. And because of the severity of COVID, there's been enough funding. There's been funding from the governments because we want to get this out. And it's been easier to recruit people for clinical trials. So more people are volunteering because either they think this is a good cause or they're getting paid for it. And one really cool thing that we've seen is that companies are sharing information about the vaccine instead of working alone and being greedy and keeping it for yourself. People like Pfizer and Moderna have been working together to make sure that they can both provide the best vaccine possible. And that's been really helpful in development because then research is split in half, so it takes half the time for both companies. And another thing we've been doing is we begin to build factories once the vaccines show promise. So everything is ready. Everything is ready for once it gets approved, we can distribute. And one thing that Canada's been doing that's pretty special is we've been doing like a pre-approval distribution. So if we know that approval is imminent, we began to send out the vaccines a little bit earlier. So they were in position and they were ready. As soon as approval hit, they could start vaccinating people. And that's how we've managed to do it so quickly. It's not rushed. We still have the same standards, and we're still testing for side effects afterward. And even in the COVID vaccine, compared to other drugs, the post-market approval processes to test for side effects, they're stricter than they would be for another drug. So we're making sure that people are safe. So this is also false. So this is my conclusion slide. Please continue to wear a mask and wash your hands. And consider the benefits versus the risks of getting vaccinated. Do I have anything else? Oh, I've got this slide here to show you some people who are getting vaccinated to promote others. This is Dolly Parton.
This is Dolly. Martha Stewart.
Yeah, we've got Dolly Parton. This is Martha Stewart. I'm sure you guys know her too. Ryan Reynolds. And this is my grandfather getting his vaccination shot. And then I have I'm hoping to distribute this presentation to you. Here are some additional resources to go over what I didn't have time to. This video here shows why you shouldn't compare the efficacy rates of the different vaccines to each other. And I would highly recommend that you watch it. And that's it.
Well, you have to watch that YouTube video.
Yeah, we can watch it. Hold on,
I'll watch it later. I'll watch it on my own.
Okay. Does anyone have any questions?
I have a question. Once we're vaccinated, is it true or false that we still can transmit the virus to others?
We don't know yet, but early studies are showing that you can't, because if the virus can't get into your cells, how can it replicate to make more? So we don't know that yet, so don't go out, get vaccinated and start breathing on people, please.
That's why we need to continue to wear the masks.
Until what? Until everybody's vaccinated?
I don't know. Until when, Casey?
Until when?
Should
Jason?
we
How
have
long do I have
herd
to wear this
immunity?
mask?
It depends how well the vaccine's working. If the vaccine works and you get it and you can never get COVID again until we hit herd immunity. But this is questionable because I don't know, because it could be until we eradicate the entire virus, and I don't know when that would ever happen.
So,
Continue to love your mask.
And buy your fancy masks.
Yeah, wear your mask.
Continue to love your mask, yes.
oh, wow.
I like my mask. I can go outside and I can like make faces and nobody knows.
There you go.
You don't wear glasses though, right?
No, I know that's a problem. I saw people putting tape on the bridge of their nose here and then putting their mask over top, and it doesn't fog up as much.
Yeah.
Electrical tape works.
That's what I want.
Staples,
Electrical
too.
tape works really well.
Staple.
Because it's not as sticky and the oil's on your face,
It's
so
very
it doesn't leave a
attractive.
residue.
Casey, I'm going tomorrow for my first shot.
Yay! Because they're doing people that are over 50 now.
Thank you, Polly.
So if we have a choice between AstraZeneca and Pfizer and Moderna, which one should we choose?
You should choose the one that can go into your arm the soonest. Whichever one that is. We shouldn't really be comparing them right now. We should be working together to stop the pandemic.
We
I'm
don't have, we only
Pardon?
have Pfizer, Moderna, and Algoma. Those are the only two.
AstraZeneca.
I think they're starting to do AstraZeneca in pharmacy settings.
Oh, okay.
And if I can get that, I would get AstraZeneca in a heartbeat. I'm not worried about the risk of blood clot.
And what about the second shot? When are we getting that?
You know, that's up to the government. I heard that they're making people wait 4 months now. I hope they have the research to back that up.
But didn't they tell us at the beginning you had to have it, the second shot after 3 weeks?
I think that's the optimal way to do it. But I think they're making us wait because of how many people need to get vaccinated.
Does that do anything to the first shot? Not
I
getting the second one? Does
I
that
don't-
diminish the effects of the first shot?
I hope that upon making this decision, the government has taken that into consideration, but I don't know.
That's the question. I wonder.
Casey, why do we have to have 2 shots? Why doesn't this work the first time?
Let me show you a fun graph that I will draw. So basically, when you get the vaccine, you get a little spike in your immune cells like this. And if it's below a threshold, you're not safe. So you do the first one and you get this, and then you do the second one and you get this, right? So that way you're above the threshold and your body has enough memory cells to actually actively fight the virus. Does that make sense?
It
Yeah.
does, but it does prove too that the first one's gonna diminish. How can it not?
I know.
Time it's gonna dilute in your body and you're gonna be even lower. Like your little hill's gonna be,
I don't want a big buddy either.
I'm hoping that we can do this and then we can stay in like a, actually, hold on. Can I undo that? Nope. I'm hoping that it'll go like this and we'll stay a little bit high, and then we'll get it and we'll still end up being able to do this. That is what I hope.
me too.
Another thing, Casey, I know people that have had the vaccine and they said they felt nothing. No swelling, no fever, no aches. Does that mean it wasn't working on them?
It's based on your immune system. That could mean that your immune system just dealt with it so fast that it didn't even they didn't even need these extra steps. Or it could mean, yeah.
But But it doesn't mean it didn't work.
No. No. So every year I hear people complain about the flu vaccine and they say, oh, my arm was swollen. I was in bed for days. Whenever I get my flu vaccine, I feel completely fine. And I have not gotten a severe case of the flu ever. I don't know. It's
I have a
just
question for
people's
Ms.
immune systems react differently.
Well, this was very, very interesting and you
Yes, thanks,
answered
Casey,
all
it's
of our
awesome.
questions pretty well that the average person has and the myths too. That, yeah.
I have, okay, go ahead. No, mine's just, my niece lives in the States. Hi, Casey, this is Gina.
Hi,
So my
Gina.
niece lives, hi, honey. My niece lives in the States. She just got her second vaccine, 2 days ago.
Mhm.
She's a teacher. Actually, her whole school just got the second vaccine. They had to close the school because all the teachers were very ill after their second shot. What do you know about, which one did they get? Pfizer.
Pfizer.
She just showed us.
And basically, yeah, they all had fever, vomiting. They had to close the school, teachers.
That's definitely a possibility. I know somebody who got the vaccine and then their arm was like so swollen for 3 days. And I understand that. That's another thing. Like you can either have no symptoms or you can have really bad symptoms. It depends on how well your immune system works. That's still probably your immune system working. But the second dose, it's a stronger immune reaction, right? You've got the one hump and the
This
second
was
hump.
from her second needle, yeah.
Yeah, so you've got all these extra cells working on your body. So that might explain why they're having so many more side effects. Hopefully they go away. If they get worse, I think, go talk to a doctor and see what they think about it.
Thank you.
I
have a question. Really good presentation, Casey. Thank you so much. Lots of good information. A lot of us were obviously worrying about and thinking about, so thank you. My one question is, if you're vaccinated, are you still protected against the variants?
That depends on, hold on, this is really hard to go back in. Oh no. Where's it going? That depends on whether the spike proteins change or not. Because the only thing we're vaccinated against is these proteins, right? So the variants are starting to change these, and that's scary. But if they don't change too much, we should still be reasonably safe. But again, keep an eye on the news, but watch out for fear mongering because they're doing that a lot.
Hi, can you hear me?
The half-life about mRNA, does that really mean that the vaccine, if it's an mRNA vaccine, is out of our body in hours or a day?
Yes and no. So we have, oh gosh, you know what, never mind. We have the stabilizers in the vaccine to make it slow down a little bit. But yes, it's not there for very long. So it probably won't be in the 2-minute range. It'll probably be closer to the 10-hour half-life. But they're also injecting you with a lot more mRNAs. So let's say they put, this is a completely arbitrary number. Let's say they put 1,000 in you. And then after 10 hours, you still have 500. They're still making spike proteins. And then after 10 more hours, you still have 250 and they're still making spike proteins. So that's kind of what's going on in an mRNA vaccine. But yeah, it's not in your body long enough for you to be concerned that it's going to touch your DNA at all.
What about people, what's your thought about people who are pregnant or are going to get pregnant? I know you said talk to the doctor, but what's the issue?
Personally, I don't see that much of an issue. If I plan to get pregnant in the future, I'm still getting the vaccine now. I can tell you that much. Oh gosh. I don't know why people are afraid of it if they're getting pregnant. I know that people have been talking about how you can pass antibodies from mother to fetus, but that's good. That means that they're protected temporarily from the virus.
So a pregnant woman that gets a vaccine is actually giving the vaccine to her unborn child at the same time.
Kind of. So we have different types of immunity. We have active immunity, which is what a virus or a vaccine does, where it actually teaches your body how to make the antibodies. And passing from mother to child is something called passive immunity, where we just give them the antibodies. So they don't know how to make it themselves. But for as long as that antibody is in their system, they can use it. Does that make sense?
Yep, it's interesting, yeah.
Yeah, the immune system is really cool, and I quite enjoy learning about it.
I appreciate your response.
Well,
No, I was just interested.
Absolutely.
Anybody else?
I don't think so, no,
Any-
so it's really,
Anybody online have any questions for Casey?
Yeah,
I see somebody raise their hand.
Matt raised his hand, but Eleanor, can you hear me?
I
Can
can hear
people
you.
hear me? Oh, you can hear me, Casey?
For
Okay.
you.
Eleanor was wondering if you have a major family history of blood clots, should you opt for the other vaccine, like in terms of AstraZeneca?
That is a good question that I don't know the answer to. I can try and do a little bit more research, and I can send it to whoever's asking the question. You know, give me a few days, and I'll do some research on it. The percentage is just, it's so low. I don't think it should be an issue, but I don't want to be wrong. So I will do research.
Hey, Casey, thanks so much for coming and giving us the presentation. Can you go back to the slide where you showed like the order of the vaccines and the different types?
Yes, this way. Oh gosh, I've added too many animations. This one?
Yes. So can you just explain, are all 4 companies using number 3, or are some using the viral vector, and why they decided to go that way?
So the mRNA vaccine is used by Pfizer and Moderna. And this is new technology. We've never made a vaccine with it before. Super cool. Not all companies are using it. Might be out of a fear factor because people might be saying, you know, I don't want to get a vaccine that doesn't have a lot of research done on it, even though it does. So this method is used by AstraZeneca and Johnson & Johnson. Sorry, I don't have my pointer out. This method. And this method's reasonably effective. And the Novavax vaccine that's not approved here yet, I don't think, is using the spike protein. So they're using different ones. And I'm not sure if they're doing that because they're afraid of a different type or if they want to give people different options. But I think it's really smart to have 3 different types of vaccines out there.
Okay, thanks.
Yeah, I think if you guys get this slide deck, I do have the examples here. I have Novavax here. I have the Johnson one here, the AstraZeneca one here, and then the Pfizer and Moderna one here. And then beside them, I have the steps on what's happening. And if you want to know more, I have a source on every slide that I've used information out of my general knowledge on. Feel free to click on them. They're interesting.
Any more questions? Hi.
We have Brit Women wondering, what are the risks to people that are immunocompromised?
Can I go back to that slide? Nope, that's fine. For people who are immunocompromised, again, you can't get the virus from the vaccine because you're not putting the whole virus in you. You're just giving them the spike proteins. So people who are immunocompromised might have a bigger or smaller reaction to the vaccine. But talk to your healthcare provider and they can bring you through it because there are different types of immunocompromisation. My advice is talk to your doctor.
Hey, what about the virus live on the surface or not? Because they're telling us they did telling us they don't. So like,
You
when
gotta-
we have people in the bowl, should we still be spraying down? Can it not actually live on a table or a chair or the door handle?
So viruses are really cool. They're not really alive. They're just bags of a genome and some proteins that can hurt you. So you should still be spraying down everything. Be it you're vaccinated or not, you might as well be safe. If you've got any particles on you, get them off you so you don't spread them around, so you don't give them to yourself, you don't give them to your family. I think that's a lot of how it spreads. We worry about the masks, but a lot of spread is contact. You touch the door handle and then you touch your face, you put it in your eye, your nose, your mouth, and then you've got it. So we should be vigilant on spraying stuff down. We should be vigilant on hand washing. And the mask is great for keeping viral particles to yourself.
That's why when you go to the grocery store, they ask you to hand sanitize. So if you do decide to touch the cereal box and not choose it, you should have that sanitization. So when you go through, I don't think that's gonna change in the next 5 years. We're gonna always have to go in the grocery store with the mask, sanitize. Even when I get into the car, I'm sanitizing before I touch my steering wheel. They still recommend you clean your groceries, whether or not. you
But I
choose to
just
do
saw
so,
on the
but yeah.
news the other day where it said it cannot live on surfaces. It
What
doesn't
news
spread.
source are you watching, Eugene?
Probably Fox.
Global. Global. What's global?
We can't live forever on surfaces, but we might as well take the safe route here.
Well, if there's one vaccine, though, you only need one shot.
Yep.
Johnson, like, how come they do one and everybody else is two? Is that theirs is that much stronger?
It could be stronger. I don't have the ingredients here because I didn't do that much research on it.
Yeah.
But some vaccines will use something called an adjuvant, and it just makes the response stronger. So it'll keep all of your viral particles in the same little area where you get your injection. So the immune response will be super duper strong right here, and then it'll make a whole bunch of memory cells that'll go and they'll stay in your body. That might be why it needs one. They might inject you with just a lot of the virus. But one of the cons of doing that is just supply. If you're injecting people with 2 milliliters of vaccine instead of half, you can't vaccinate as many people.
But then I heard that Johnson and Johnson, the one shot only protects you 67%, where the others after the second shot, you're 90-some% protected.
Yes. So
6%.
Is it?
Yeah.
Gotta watch that YouTube.
yeah, so this YouTube video, I'd strongly encourage everybody to watch it. And it tells you, so that efficacy value, it's not the greatest measurement because it will change based on when you did your studies. So let's say here is, a spike. We've got this, and then cases go, whoop, and then they go down here and they do whatever. So Pfizer and Moderna did their clinical trials here. So that's why their numbers are higher. And Johnson & Johnson did theirs here. So their numbers of efficacy will just be lower because that's just what happens. And they explain that a lot better in the video. That's why I have it bolded here.
We're gonna get a copy of these. Perfect.
Yeah, I can send this to anybody who wants them. I would love it if people would share this.
Yeah.
Yeah, I have a
I
teacher
would,
in
yeah,
my house.
I
I'm
would love
sending it
that.
to him.
Casey, can you put some contact information on that in case people want to get a hold of you?
Absolutely. I'll put it on the first slide. Yeah, feel free to email me with questions. I can do research. With me being in university, I have access to databases without having to pay for them, which is really nice. So I can get articles for you guys,
Awesome.
whatever we need.
Well, thanks very much, Casey.
Thank you.
Casey, on behalf of the Wishart team, we thank you so much.
Thank
It
you.
was a great presentation.
If you want to stop in, we have pizza.
Yeah.
She's grounded.
Yeah.
Thanks.
Thank you very much.
Thank you.
Thank you.
She's cute.
Oh, is she ever?
Okay, hey, Paul, she sounds just like her mom.
She must, eh?
I asked, I said that, Jeannie, but I heard CNN being like, don't go to Canada because the Canadian numbers are so